should I roll my dice?
Yes, Crewton Ramone's House of Math. So, you're saying you get the hundreds wrong, and let's get rid of this. This is not your lesson, this is a different lesson.
I mean, so I'm right, like, I'm very off on it, but it's very inconsistent.
Inconsistent, yes. So pay attention to this simple idea. Count the big ones. Count the big ones.
Numbers that I just get.
Right, count the big ones first. Okay? So count the big ones first. That's the idea for today.
Roll.
I don't know.
I'm so mad at what I just rolled.
What did you just roll?
A 10 and a 1.
Okay. Okay. So what's 100 times 1?
100 times 1? 100.
All right. What's 100 times 2?
100 times 2 is 200.
All right. It never gets harder than this. If we're just going to get the numbers be bigger, right? Because what you're saying is that you double-digit multiplication, you got it, but a lot of times you get the triple-digit multiplication, you have problems with that.
Like 472 times 765. Like that, I get wrong a lot.
Okay. Let's fool around with that. But let's start smaller.
Yeah, like not.
Because last week we were having fun time doing double digits. Let's do triple digits. So let's just start off with something simple like 121. It just so happens to be a cube. And since you rolled a 10 and a 1, let's make it 11.
1.
Alright. You froze. You're freezing. What the heck? Let me see if I've got the right router going on here. Nope, everything should be good. Alright. If we have too many more freezing episodes, I'm gonna hang up and call you back on a different line, on a different router. But anyway, we should be fine. Okay, so 121, what do you gotta do? Well, count the big ones first. So it's 1,210, 1,210, right? That's 10 times 121. And then just 121, right?
Yeah.
Oh. And what do you get?
Let me first, wait, that's the
I mean, really, we're just adding, right? I mean, it should be pretty simple, I would expect. Oh, this camera stand is terrible. That's about as good as it's going to get, and it looks sideways, but anyway, you can see it. It'll be fine. Ow.
So it is 12, 13, 31.
There you go. Done. Right? And that just so happens to be the same thing as 11 cubed, by the way, because 11 times 11 is 121, and times 11, right? So this is the same thing as, just for fun, practicing our cubes. All right, so let's roll your dice and let's pick a different number.
Okay.
And we're just going to take it in parts.
20? Oh, perfect numbers. 20 and 13.
Okay, so let's make it 213. Right?
Okay.
20, 13. All right. And then roll one more time.
8.
All right. First, we're going to do it 8 times. Then we're going to do it 18 times. Right?
So, times 8?
Times 8.
So 8 times 200.
Now, here's the thing. We've got 3 parts, right?
Yeah.
And we could draw this, but we've got 3 parts. We've got the hundreds, the tens, and the units.
Yep.
And because we're in base 10, we're going to carry because we're going to have some 24. That means there's going to be some tens here, right? There's not going to be any hundreds here because they're just 8 times 10. But anyway, what do we get? 16.
Well, you listening to now I just started adding.
Right, so 1,600. And then what?
8 times 3.
And then 8 times 10 is just 80, right?
It equals 1624.
Wait a second, you're off by just a little bit. Think some more.
Oh, 80 more, so then it's 1704.
There you go. Got it.
I missed 80. I forgot to count 80.
Right, there you go. That's kind of important, right?
Yeah.
So we add all these guys up. And how is it on your screen? Okay, I can move up a little bit more on this screen. All right, so trying to get multiple cameras and so forth going. All right, so yeah, we right here. This is the only action, right?
Yeah.
We got an extra 100 over here hiding.
I forgot to add the 80 because 8 times 13 is 104, not 20.
All right. So now let's make this 18. Now what are we going to do? We're going to have one more set of numbers, right? So I'm going to write this over here. I'm going to have 1600. I'm going to have my 80. I'm going to have my 24. And then what? I'm going to have 10 times this, right? Like I said, count the big ones first. So I'm going to put that right here. Hopefully you can see it. We're going to have 2,130, right? Just 10 times?
Yeah.
All right. Oh, let's write that actually over here. So what did I have? I had 213 18 times. There they all are.
Wait, now 213 times.
Now, can we go this way?
Yeah.
Because I'm going to have a 10 there, so I'm going to have an extra one over here. So I'm going to just go this way. 3, that's not going to be 7 anymore. It's going to be 8.
Yeah, so
3, 4.
Yep.
Is that what you got?
Yep.
Does that make sense?
Well, now, let me calculate it my way and see what happens.
Okay. What's your way?
Tic-tac-toe board way.
Oh, I know what you're doing. Let's show me. Well, after you get done, let's show me. That makes things, that's a way to do it, but it makes things a little hard, as you noticed.
That's how I do it, because the other way is a little harder for me.
I had a student that that was his, and he always used to get annoyed because I was so much faster than him doing it this way than he was doing it that way. But anyway, show me your work when you get done. Once you get finished. Yeah, once you get finished.
And 10 times 13 is 230.
And let's take a moment and just for the fun of it, draw this.
8
at how
times
spacious I am.
2 plus 16.
Because I'm going to have, do I have? Yes, I do. I'm going to have 2 hundreds.
Okay, now
Ah, you froze again. Oh, total froze, blackout, everything. All right, let's change routers over here.
Coach.
I'll tell you what. Let me.
There.
Yeah, you're back. I'll tell you what. I'm gonna hang up and I'm gonna call you right back. So just answer when I call you, okay?
Okay.
All right. I'm going to change my router. See if that gives me a better connection. And then I'm going to call him. Oh, he didn't hang up. Oh no. All right. Well, let's see what happens. Wow, the glare is terrible also. All right, how's that?
That's good.
All right, and let me go get something to cover this glare.
No, it worked.
I know. I'm talking about the glare on the board.
It's glitching. It's glitching a lot. Like, we just got in resolved and it's still glitching.
What does that mean?
It's glitching.
Glitching meaning it's working or it's not working?
Glitching.
Well, it was glitching, now it's working. Uh-oh. And then they disappeared. What happened? Let's try one more time. Okay, how's that?
That's good.
Alright. So like I said, we're gonna draw this.
I'll show you my
And see,
one.
I got rid of the glare. Yeah, but hold on a second. Let's just draw this one fast one. So I've got 2 hundreds, but these are the long, skinny 100 strips, right?
Let me get my red. Here's red.
Yeah, get your pencils. And then let's see here. I've got a 10.
Blue.
Yep. And then I have 3.
Green.
I'll just do 1, 2, 3.
I've got green right now.
All right, that's the across.
Green.
Oops, what am I doing? Draws it incorrectly. That's the across. This is the up. So now we got to go up 10 and 8.
There, green's back.
So I'm going to wind up with, that's a 10. That's a 10.
No, it's gonna make that.
This, oh my goodness, that's terrible drawing. Oh my goodness, that's bad. All right, there you go. That's better.
That's very bad.
Now I'm up 10 so far, right? So that would make this 100. That would make this 3 10s. Look what I just did. I just drew that, right? 2,130. There it is. I just drew it. Right? Now I have to go up 8 more. So I could do 1, 2, 3, 4, 5, 6, 7, 8. I have a lot of kids that do that, but you know what? I'm just gonna do that. I'm gonna do that. Those are 8. And then I'm gonna do this. That's the 1600 right there. And then there's that right there. That's the 80 right there. And then these are 8s. 1, 2, 3 8s, which is 24. There's my drawing. And all we're doing is counting this thing up. And we're trying to count it in the most efficient way possible, and the most efficient way to count this is by counting the big ones first. And if you wanted to get all crazy on me, you could label this that that's 1,000, that's 1,000, that's 100, right? This is 800s. This is 8. I'm just looking at what he's doing. 800s. There's my 80. Right there's my 24.
Oh,
right there's my 30. See? And then this right here, all of this right there is that right there in symbols. And then all of this right there is broken up into this part, boom, that part, boom, and that part, boom, 3 parts.
Why do I have a feeling that my answer is going to be way too high?
It's not. Your answer is going to be 38, 34.
That's 8. That's 18 times.
That's 8. There you go. That's 18 times 213. And then see, if I turn this, if I made that a 2, I'd have, yeah. You're just drawing it. Are you using graph paper?
No.
Okay. You're just using regular filler paper?
Yeah.
Alright. So then if I had 2 over here, then I'd have 2 of these. And if I had 3 over here, I'd have 3 of these. I love it. Doing the calculations. Would you call it multiplicating? You're multiplying. And if you have graph paper, you could make this even bigger and have even more fun. And then, of course, if you have basic operations pieces, there they are.
Right. It's way too high. It's 4174.
Oh, what did you do?
I don't know.
Okay, how did you get 4? How'd you wind up with 4 thousands?
I figured out what I did wrong.
What did you do wrong? That's the important part. And see, I'm not figuring it out for you. You're figuring it out for you, right?
It's 2600. 2600, not.
It's 1600. There's no 26. It's 8 times 200 gives me 1600. There they are. 8 times 10 gives me 80. There it is. 8 times 3 gives me 24. There it is.
Oh, I figured out.
And then over here, when I take my 10 times 213, there it is. Boom. 213, 10 times gives me 2,130.
Yeah.
Yeah, alright, so what's the problem? Where did you get extra stuff? Wow, he looks very pensive. Where's your extra stuff? Because you can't, there's no way you can come up with 4. There's only 3. I mean, there's only 7 there. Well, actually 8 there.
Should I use a calculator to calculate my steps?
Sure.
And see if I made up.
Alright.
Okay, I have one. So.
See, that other way of doing it, I'm telling you, it's confusing. He's trying to do this thing. Show me your, that's why you're getting confused. And see, this is absolutely worth the time because it lets them see what's happening when they multiply. And he's figuring it out for himself, right? Right now, he's doing all kind of calculations and looking at his joints. All right, pick up your notepad and show me your work. Oh, jeez. Yeah, there is the problem. All right, so here's what I want you to do. Flip that piece of paper over. I hope you didn't bust your calculator. They're solid state, so it should be okay. All right, flip that piece of paper over and draw this carefully. In fact, do you have graph paper?
No.
Yes, you do. In your whole house, your brother or your mom or somebody has graph paper.
No, I don't think so.
I do. Go get. Are you kidding? Your brother, especially. I know for a fact because we were working. Anyway, go ask your brother if you can have a sheet of graph paper.
Yeah.
Because he wasn't even using filler paper, he was using just a plain white sheet of paper, and at this age, he needs some guidelines. Easy for me, not so easy for him. But see, this is one more lesson wherein the student is directing it, because he asked me, look, I can do double digit, because last week, if you can see the video where we were just playing and having fun, and he had a great time. And then he threw in that extra digit, and you would think that it would be easy, but it's not. They need to get some experience with it and get their hands on it, be able to draw it, and be able to see the various portions, and then understand the concept. Count the big ones first, and then put them together. Super easy. If you do it the other way around, and I know that this is not the algorithm your children will see in school, see what I tell you! What I tell you! I knew you had some graph paper in the house.
Okay.
All right, now very carefully draw this.
On graph paper?
Yes, on your graph paper. Put this near the top. Instead on yours, I want you to put this near the top, and we'll put the symbols and stuff like that underneath it. But now the deal is, this is 100. Here's what you're actually drawing is these guys, right?
Mm-hmm.
This is see how it's 100 by 10, which gives me 1,000.
Yeah.
And then I have more multi-tens around here. Oh jeez, I just cleaned everything up. Therefore, it's going to be difficult to find them. Jeez. Oh, I know where they are. They're right here.
You're covering the picture.
I'm sorry. Let's see here.
The one above 1,000, what is it?
Excuse me?
I can't see I can see 1,000 and 1,000.
Yeah.
And then 100, but I can't see the top.
Okay. Because I was in the way? Here, I'll take
No,
that.
because I couldn't read it.
Alright, hold on a second. I'm gonna move everything. Get you closer.
Is it 800 on top of the 1,000?
Yes, that's an 800. Those are 8 100 strips. Right? And then see, that one right there is this one right here.
Yeah.
And these guys right here, 3 of them.
100.
And then I'd have 8 of them this way. And then I'd have, here is a one I've broken. This would be 100, except that I broke it. Right?
Okay,
this would be 10 of these. Right now
I
this is,
added the numbers up and they went to 37.
yeah, there would be 8 of these 100 strips right here, 2 rows of them. But see, that's why it's easier to just draw these babies than it is to, right? But if you've got basic operations pieces, build these. And guess what? Your little kids, and I mean little kids, like 7-year-olds, can build these. They're fun to build, and then you just count them. And then you show them the efficient way of counting. I like your shirt, by the way.
Thanks.
Have you been playing basketball?
Yeah.
Have you been playing basketball lately? Can you shoot free throws?
Yeah.
Can you?
Yeah.
Wow.
37, 80,
Right.
37,
38, right?
Yeah.
Look, you got 30. There's your 37 right there. There's your extra 100 right there.
10,
And then you got 34 left over.
38, 34.
Bam! Got it. Now, just for giggles, let's make this 2. New problem. New drawing. I'm just going to add to this drawing, but you're going to draw a new one. And look, what am I going to have? I'm going to have bam, bam, drawing not to scale. Another 100 over here. And more 10s over here. Boom, boom, boom. See it?
Yeah.
Alright, so now what I do? Well, now instead of having 2,130 over there, I'm going to have 4,260, right? 4,260. See it?
Yes.
4,260. Now what do I have?
46.
And let's make a story. You want to make a story?
Sure.
Let's say I had 28 boatloads, and each boatload had for some reason they had 213 bricks in 28 loads. How many bricks do I have?
I am counting.
Alright, I am counting. Alright, count the big ones. 5,000. Right?
And yeah.
Now here's the thing. Can you see that I'm going to have 8 there, but uh-oh, I've got, right? Again, I'm going to have 100 hiding, so I'm going to have a 9.
5964. 5964.
Bam, got it. Good job. So you'd have, if you had 213 bricks in 28 boatloads, you'd have 5,964 bricks.
Yeah.
And there's the picture of it. Let's see your picture. Yeah, hold it up to the camera, fast one. And then let me take a... Oh, except for one... Oh, I see. But you gotta... Okay, label these guys, by the way. Just... Okay, I see. You. Right. He's a little sloppy because he's 7. And then 30 again. And in fact, I could just make this boonk 30, boonk 30, boonk 24. What are we doing? We're counting up rectangles, for Pete's sakes. That's all we're doing. Build stuff and count it. And then learn how to count it quickly and easily. Then pretty soon you can you can count them in your head. All right, yes, I agree. Are you good with this though? Did you label everything? Let's see. Did you label everything?
Yeah.
Let's see it. Trust but verify. Very good. Yes, good job. All right, do it again.
A 7 and a 5.
Ooh, let's make that. Oh, this will be a fun one. It'll be easy too. 750.
Go.
Yeah, nice big number. And then roll another one.
7, 5, 0.
Mm-hmm.
11.
You want to do it 11 times? That's actually too easy,
Sure.
but all right, we'll do it. We'll do it. Okay, I want you to draw a picture of it. I'm going to use symbols only. You're going to draw a picture. All right, and this is going to be a pretty big picture, so you're going to have to scale your picture down because, look, you got 7 hundreds and 5 tens, right?
Yeah.
All right. So if we count the big ones first, this is super easy because it's just 7,500, right? 10 times.
Okay.
And then 750. Boom. But I want you to draw it.
First, I'm gonna
We're going to add those.
go. Calculating. And this is not gonna be long because now all I have to do is add.
Yes. And the only action, when you get right down to it, is right there. But you know how to do that, right? What's 7 and 5?
7 and 5
Mm-hmm.
is 12.
Done,
I
right?
already did all the multiplying. Now
All
I'm
right, so
adding.
this is going to be 8, 2, 5, 0. Done. Because I know there's a 12 here, right? In fact, I can do it like this if you want to. 1 and then the 2. Because 500s and 700s is 1200s. So I have an extra 1,000. 1200, another word for 1200 is 1,200, right?
82.55.
Where'd you get the 5? Where'd you get the 5?
1 times. Oh, it's 50, not 5.
Yes, there you go. There's no 55 there. It's just 5, right? 5, 0. 0 and 0 is 0. Yeah, yep. What's the idea? All we gotta do is practice, right?
So that's where I am wrong.
Yeah, there you go.
'Cause
I don't know how you came up with a 55, but it's alright.
I did 1 times. Because, like, for some reason I didn't see the 0
Okay.
on 50.
Yep. Alright, now let's hear. Can I see your drawing, please?
I'm just going to draw it now. 'cause I
Yeah,
think
there
I
you go.
stopped
Make a
it
drawing
right
for
there.
me on fast one. And I'm gonna draw it. I'm gonna draw it in a small scale over here. Where can I put it? There's no way to fit it. It'd have to be 1, 2, 3, 4, 5, 6, 7. Those are hundreds.
There's so many hundreds.
And I know. And then you have to do 1, 2, 3, 4, 5 in blue, and then none of them, and then go up. Right? Then go up. Jeez. This is a terrible drawing. And then one more right there. Right? Anyway.
That's all the hundreds.
Yeah.
And then the 50.
Yeah. You'd need a couple of basic operations pieces, a couple of basic operations kits to build this one.
Yeah.
And you can cut them out. Let's see it. I don't like it so much. Oh, okay, sure. I'll take it. You know what we could do?
What?
We could do 5,000 block, and then 2 700, or then 2 1,000 blocks, and then a 50 block, and then bam, 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 bam. We gotta use our imagination. We can make these be anything we want, right?
Yeah.
All right, so that would be 5 of them, and then 2 more of them, and then a 50.
Yeah.
And that's totally not to scale. These guys should be, anyway. All right, let's do another one. And you know what? Let's do some algebra, because I mean, doing this over and over again, you're gonna get bored pretty soon. But while you're still focused, we're good. We've only done a few problems, so let's do another one, and then we'll do something else.
I'm never going to get bored of this. I really want to learn what I'm doing wrong on hundreds.
Okay.
So I'm never going to get bored
All
of
right, if you're interested, good. Like I said, that's the idea.
this. Perfect numbers with a 19 and a 16.
All right, let's keep that one a little smaller. 190, 16 times.
Oh, that's really easy.
I hope so.
But of course it takes me a long time to draw the picture.
And there's other Vedic ways to do this, because this is close to 200, but I'm going to skip that for now. because we could do it by doing subtraction, but we're not gonna.
6 times 9 is 50.
Wait, count the big ones first. How many times I gotta tell you? If I tell you once, I tell you 10.
The big ones.
All right, well, count the big ones. The big ones are gonna be 1,900.
1,000, yeah, 9, yeah.
Right? That's
9.
10 times that. And then I gotta do 6 times that is 600. What's 6 times 9?
6 times 9 is 6 times, 6 times 9 is 54.
But it's 6 times 90, so it's 540, not just 54,
Yeah.
right? And then 6 times 0 is 0. I don't have to put anything down there.
I
Right?
have the 6, I have the 1,000,
Yep.
I have the 540,
Yep.
I have the 600,
Make it.
I have,
Trying to get everything to fit over here.
I found my 900, I made a mistake.
Okay, I'm seeing you're catching your own mistakes. I don't have to tell him, oh, you're wrong. Right? He's catching his own stuff. There you go. Now everything fits nicely.
Oh, there.
Bam, zeros. No action, no action. You got to do a little thinking over here.
1,000. 1,000.
And I would take the time to draw it. And I would take the time.
40, 2640, 2640.
Wait a second. How much is this? What's 5 and 6?
11.
What's and another 9?
I don't know.
What's 11 and 9?
11 and 9, 20.
All right. So 2, 0, 4. Right. What's 2 and 1?
2 and 1 is 3.
Compare and contrast my answer with your answer.
Okay. First,
Because you see that when I have 500, 600, and 900, I get 2,000s.
what did I do wrong?
I know what you did wrong. You didn't carry. You didn't, right? But you find out what you did wrong.
I'm mad.
Oh. Well, don't be mad. Be happy you found the answer yourself.
Wait, what? This one, like, let me take a
All
moment.
right, is this what you have right there on your paper?
1900, 600, and 540, yeah.
All right, then what's the problem? Dude, you're not, see, at the moment, you're not having trouble multiplying, you're having trouble adding.
I added an extra 6.
Yeah, you can't just make stuff up, right? So that one's no problem. That one's no problem. This is the only place where there was action. Right? And you had to figure out that that's 2,000s, all of this, all of these hundreds.
600.
Yep. And then I add it to the 1,000 and I get 3,000.
I should be, my answer should be higher than yours.
Your answer should be the same as mine. What do you mean?
Because I added an extra 600.
Oh, well, how'd you get an extra 600?
But I should be higher than you if I added an extra
Yes, you should.
Oh, well, then what's the problem?
I don't know. What's the problem? Like I said, you're having trouble. You're not having trouble multiplying. You're having trouble adding. Show me your work for a second. Hold it up.
Oh, this is 2,500, not 1,500.
Where are you getting 2,500? Are you doing 190 times 16?
What?
Are you doing 190 times 16? Are we doing the same problem? Show me your work, darn it. Pick up your piece of paper and hold it up to the camera.
1,800 plus 600, 20.
Well, right there, can you see right there is 2,500?
Yes.
All right, and then 500 more. 3,000, and then the 40.
That's what I did wrong.
Yeah, there you go, see? I'm just pointing it out.
Put an extra
Darn it,
100.
take your piece of paper and hold it up to the camera so I can see it. To the camera, move it over to the other, move it over, in front of the camera. There is your issue right there. All right, so, right?
It's what?
Yes.
1,500. It's 2,500.
There you go, right?
I added 600.
But that's what I'm saying. You got to take it in pieces. Take it in 3 pieces. How many pieces are there? There's 1 piece right there. Is easy, right? What do? That's this right here times that right there gives you that right there, right? Yeah. And then we took it in 2 pieces, 654. And if there are some numbers there, we'd have another row right over here to get the units, right? But yes, because we got a 0, there's nothing there. Yeah. All right, let's try another one. Let's try another one. Get your dice, roll.
At least I'm happy that I figured out what I'm doing wrong.
There you go. That's what I mean. Don't be mad, be happy.
My multiplication is correct.
Yes, your addition is where you're stumbling.
It's just...
like I said, don't be mad.
11 and 9.
All right, let's call that... I'll tell you what, 11 and 9, we'll call that 119. What do you say?
100?
Yeah, just to make it sound fun. And then roll one more time. And then roll one more time.
119, let me write that down.
Yeah. We're working on 3-digit multiplication. Notice we're still just doing 1 and 2s. We'll make this 2 problems. Roll a dice, roll a dice.
11.
Oh, do it again. Too easy, too easy. Oh my goodness. Oh, take it easy.
16.
All right, let's do 16. I like it. I'll tell you what. At first, let's do 6, and then let's do 16. What do you say?
Oh, that's like too easy.
Oh, well, let's make sure, right? And that's the idea, is to keep it in baby steps, right? So, we're going to have 3 parts here. We're going to have 600s. We're going to have 60. And what's 6 times 9?
104.
Wait, what's 6 times 9?
704. 704. 704.
Well, hold on a second. What's 6 times 9?
6 times 9 is 54.
All right. So try again. Dude, what's 6 and 5?
704, yeah, I'm right.
One more time. What's 6 and 5? If this was 44, you'd be right. What's 6 and 5? 11. So 1 and 1, that's 714. You cannot be off by 10, buddy. Ooh. Heavy duty. You're looking perplexed. Don't be perplexed. What is 6 and 5?
6 and 5 is 11.
There you go. So that's why you've got that extra 1, and that, right?
Yeah.
All right.
6 times the 100
is 600. There you go. So you got 700 because 50 and 60 is 110.
Yeah.
So you got 7 and then 4. And look, there's no action in this row. The only place that's causing you problems is right there.
6 times 10 equals 60. 6 times 9 equals 54.
Mm-hmm. And 6 times 100 is 600. One more time, child. Count the big ones first.
Okay, so 6 times 100 is 700.
Wait a minute. 6 times 100 is 600.
600, yeah.
Yeah.
No, I did wrong because that's what I roll in my thing.
Ah, there you
go.
And
then 6 times 10 is 60.
Bam.
6 times 9 is 54.
Bam.
And 60.
And we are adding.
60 plus 50 is 110.
There you go.
And then the 4, that's what I did wrong. I did the adding wrong.
There you go. So that's what I mean. You're not having trouble multiplying. You're having trouble adding for some reason. All right, let's try this one. Now, it's going to be the same thing, except what's 10 times 119?
119?
Yes, that's what we got here. What's 10 times that?
10 times 119.
Just throw a 0 on there.
I take them into littler steps and I do 10 times 100.
Yeah, don't do that. Just do it all at once. Dude, we love base 10 mathematics because then I can just throw a 0 on there and I'm done. 1, 1, 9, 0. Done. And then it's the same thing as this. 600, 60, and 54. Now, take your time, right? Don't get all crazy on me. Just take your time and add them up. We're going to have some action here, and we're going to have some action here. That's it. Actually, there's not really any action there. And look, we've got 11 and 9 again. So then I'm going to be taking, what am I going to do here? I'm going to be, what's 11 and 9 again?
11 and 9 is 20.
There you go. All right, so we should be all happy. 1, 7.
790.
This is 9.
1894. 1894.
Oh, dude, come on.
Don't tell me you got it wrong again.
You kind of got it off. Because that's 700 and 2 more hundreds. You forgot to put the 200s. What's 700 and 200s?
What?
What's 700 and 2 more hundreds?
It keeps lagging. What did you say?
I know, I saw it lag. 700 and 2 more hundreds.
700 and 2 more hundreds? 900.
Bam! See it? Like I said, take your time. He's pondering. I like it. Like I said, I'm not gonna tell you where your error is. You tell me where your error is.
I use my same graph, same multiplication, because I know that that's right. And then I added it again.
Got this. Now this is the only place, right? There's 11 and 9 more. You got 2 hundreds here. All of these 10s add up to 20 10s, which is 2 hundreds. 2 hundreds and 7 hundreds is 9 hundreds.
That's still not what I'm getting.
Oh my goodness. Well then spend some time figuring out.
Okay.
Look at mine. Look, wait, stop. Look at mine.
I think I figured out what I did wrong.
Okay, but look at mine.
Oh, I think I figured out what I did wrong.
Okay, what'd you do wrong?
I did 6 times 19 is 104.
That's problematic right there, it is. Well, no, that's not, but it is 104. You just put these guys together. But like I said, break it into parts.
No. 6 times 10 is 60. 6 times 9 is 54. And that's 104. Yeah, so that's not wrong.
That's not wrong. That's correct. So you got this part, and you just put yours together. But like I said, bust it into parts, and then count it. I'm gonna make you draw this one too. I'm totally gonna make you draw this one.
Yeah, I got that wrong. I can't find what honestly, I can't find what I did wrong.
I can see where your problem is here. But anyway, draw this. I'm gonna draw it with you. Because see, we got this one. It's the same, right? There's your 714 right there. And then we just added this part right there, 10 times this.
Yeah.
Right? Because that part right there is the same.
See who's right, okay?
Okay, I know who's right.
It's probably going to be the one that's right.
Yeah, probably. Look, that right there and that right there are the same. Because obviously this right here and this right here are the same. The only thing you had is this right there. Now I don't understand how we just added 10 times more. We didn't even make this 2 or 3. We just made it that at 10, and you had some issues. So take a second, get your colored pencils out, and draw this.
Okay.
Okay. I am going to move everything over till, can I do it? Yeah, I'm going to move everything over till here. I'm going to make this 16. I'm going to put this in
190,
600, 54. That's fine. We'll have to fudge it. Do you have red?
Yes.
All right. So 100. So 100 strip.
Okay.
And then 110. And oof, 9 units. This is 9 of them. And I'm not going to do 1, 2, 3, 4, 6, 7, 8, 9. I'm just going to do a rectangle. All right, then what? So I went over 119. And this should be shorter. Trying not to scale. We'll make this a little longer. And then we'll make this almost as long as the blue one, but not quite. There you go. All right, now how far up do we have to go? Well, we have to go up 10. Boom. Right? So look, here's what I'm going to do. There's my 1,190. That would be, what did I just do with those? They're there. That would be, and see, I should take my camera with me. I got another lesson I'm going to do, and we're going to do radicals, but that would be these guys right here. Right? 9 of them. Now, I've got to go up 6 more, because so far I've only gone up 10 more. So far I've only counted this much right here. I've only drawn this much right here. 1,190. Now I have to do 6 of these guys. So technically, I could do it. 1, 2, 3, 4, 5, 600 strips. But see, that's why it's sloppy, so I'm not going to do that. But I would have 600 strips there. So I'm just going to draw it like this. 600 strips. Boom. What is that? That's 600. That's this right here. Now what? 60. Bam, right here. And then 6 times 9 in the corner right there is 54. And I'm going to take a second with my black pen and label everything. So here's my 1,190. Here's my 660 and 54. Now, you can use all kind of algorithms. You can use the other algorithm that they use in school, which is painful to me. 6 times 9 is 54, carry the 5, and all that's it, yeah. Or you can count the big ones first. Or you can use your algorithm, which is confusing you.
It's not that word that's confusing me. It's my addition. I'm just getting it wrong.
That's what I'm saying. Yeah, there you go.
My algorithm is perfect. My multiplication is like perfect.
All right.
I'm just getting it. I'm doing the same thing as you adding.
I will not argue the point.
I'm adding wrong.
All right. So, bam, I'm going this way, right? I don't usually bother trying to teach kids to go, right? Because look, there's my 4. There's my 2, 0. There is my 7 and 2 is 9. And there, well.
I mean, look at my question and see what I did and still figure what I did wrong. It was 119 times 16.
So do you have 1904?
Where?
The answer, 119 16 times.
No, I'm still looking at it.
We can go the other way. Let's go the other way. Do a little thinking ahead. Let's see. Am I going to have more? I got to look at these 2 columns. Am I going to have more than 1,000 there? Why, no, because I have 700 and I'm only going to add 2 more 100. So it's 1. Then I have 7. Oops, but I don't have 7 because I have 2 hundreds hiding over here with the 10s. So I have 9. And then I don't have.
Right?
Okay. Punch it. 16 times 19.
I did 16 times. I did 16 times 119, and you were right.
Of course. I'm not surprised. But this is why multiplication. Look, here it is. Here it is. This right here is that right there. This portion right there, and then this right here is that right there, and then this right here will go all the way around is that right there, and then this right here is that right there. All we're doing is counting these guys up. And we're counting them up efficiently and quickly by counting the big ones first.
You know what? Since I can't figure out what I did wrong.
How come you can't figure out what you did wrong? Think about it for a moment. Just take a look at yours and take a look at mine, and compare and contrast. This is also extremely important skill.
1,190, 616, 54.
Yep.
I have 60, 54.
Yeah, so you got these two. What about that?
600 I have.
What about that?
1,000 I put with the 600.
Don't do that. Keep it separate. 1,190. 10 times that. Dude, that's the easiest part. We're base 10 mathematics. 10 times that. I just throw a 0 on there and I'm done. We love base 10. Eventually, perhaps you and your brother and I will fool around with some other bases, like base 5 and base 2 and so on. Oh, don't get frustrated. Don't get frustrated. Look at me. Look over here.
You know, I'm going to add it the way that you did and see if I come with your answer.
All right, good. Let's try that.
Let's see if that works.
Okay.
Because I know you have the same steps as me.
Yeah.
Just I'm not coming to the same answer as you.
Yeah, there you go. Well, the only thing you're missing is this one right here. Wow, 1 hour of multiplication. No algebra, no trig, no nothing. Just working on this because he is determined. Now, here's the thing I'll tell you. Since we just spent an hour doing this.
More off.
What's that?
I got even more off.
How do you get even more off?
I got the 1844.
Oh, I don't know. Oh, because you're gonna leave. You left off the 60. That would give you the 40. And that, yeah, there you go. You left out the 60.
No, I did 60 plus 54. 104.
Well, then you did something off there because if you left off the 60, that'll give you 1844. So you're off by 6/10. You failed to count that one right there.
No, I counted that. 60 plus 54 equals 104. That's what I put.
All right, well then let's do it. Let's get rid of this stuff right here and say, look, if you've got 104 because you just added those two together, and then you've got 600, how much is that?
704.
All right, I like it. 704. We're doing it complete. We're just deconstructing this. Now I'm going to add 1190. Now here's the problem. 60 and 54 is not 104.
It's 1894 on yours.
Wow, stop it. What's 6 and 5?
11.
Well, then why do you have a 10 over here?
What do you mean?
You said that 60 and 54 was 104. 60 and 54 is 114, which makes this 714.
That's what I did wrong there.
That's what you did wrong. There you go. You're adding 6 and 5. This is why we got to work on addends all the time.
11.
Yes, there you go. There you go. 6 and 5 is 11, not 10. Exactly.
Now I'm hearing what you're saying.
All right, now we're happy. Right?
And the next one I'm determined to get right because it's probably going to be our last one.
Yes, it will be our last one. We're actually over time, but it's fine. Let's do one more.
Yeah, one more.
I gotta go, and after this I gotta run because I gotta go pick up a little boy.
12 and 5.
Alright. But see, this is why we work on the addends. This is why you can't. 6 and 5 will never be 10.
Yeah.
All right.
Well, 152 I should do, because 12 and 5
All right, let's do 152 times what?
2.
Don't go too easy. We'll make it 12. 152, 12 times.
Now I'm not going to get undetermined.
That 2 would just be 304, right? I mean, I can do those in my head. Come on. All right, he's determined. I love it. That's a good thing. I like it when you're determined. Now, darn it, count the big ones first. What is 10 times 152?
I'm just going to break this.
Dude, you're going to break it into you're going to break it into 4 parts here. What is 10 times 152? Answer the question.
15. Wait.
1,500.
1520.
There you go.
1520.
1,520. I like it. Now, 2 times 1 is 200. That's 2 times 100. 2 times 5 is 10. Right? 10 tens.
Yeah.
2 times 2 is 4. Where is the action? There is no action. And here, we'll move it over here so you can see it. 15, 20. Because now all we're doing is addition, for Pete's sakes. 200.
Okay, before I came up, is it 1824?
Yes, that is the correct answer. You got it right. Happy. He's doing the happy dance. Yes, all right. Here, give me a high five through the computer. High five, high five, high five. Bam. There you go. Good stuff. All right. You got it right. There you go. All right. So we end on a high note. You got it correct with no problem. Yeah. There you go. He's doing the chunky monkey. Excellent. All right. Okay, little boy. I will see you in a week.
Yep.
Now here's the
Bye.
thing. Just wait. Hold on. Just practice. Right?
I will.
And I'm telling
Solo.
you, count the big solo exactly without me. Count the big ones first, and then you've got your calculator so you can check.
Yeah.
Right? And then don't be afraid to draw a couple of these so you can count them up. But yeah, you got it. Right? I love it. See? Well, it's fun when you get it right, right?
Yes.
All right, excellent. I'm happy for you. All right, we'll talk to you in a week from now.
Bye.
All right, take it easy. Bye. CrewtonRamone'sHouseOfMath.com for more.